We've got a piece out of this clay, or the predecessor to this clay, maybe, that's been, it goes from the freezer to the or the refrigerator to the 450-degree oven far too often, and it's held up. But you really can't ask clay to be everything in that regard. Although, come real close. So it's up on feet. And so we have to make a big decision now as to what is the front and what is the back of the pot. And as much as I've tried, it's always one way or the other, so there's a little more space here for me than here. So I debate this one as to whether the pot's accelerating or the pot's braking. And so I've decided it needs to accelerate, so I'm going to put the spout on this side.
It's all about the card.
I always think that's a funny thing when you look at like that book 500 teapots or whatever it is. You look in there and you go, what are you doing? You want it to be taking off, or at least I. How many of you have never had the experience of making a teapot spout? Most of you. You have this thing going on. You've got this twist, this torque, and you're throwing. You're all throwing on the wheel. And so your wheel is going counterclockwise, hopefully. And that torque is going in a clockwise fashion from your fingers and the pressure. And this spout is going to, in the process of drying and firing, it's going to twist. So I wasn't listening when my professor talked about this subject. So when I actually made my first teapots, I analyzed it, and I decided that what was going to happen was that the twist is going like this, and in the shrinking and the drying, it should untwist. That was the logic I worked on, and so I made a series of teapots based on that, and I was wrong. So I had these teapots that had these spouts in them. So what you need to understand is that the spout is going to continue to twist, and you can avoid this issue if all you make is a simple funnel and you don't cut the end. But if you put a bend in it and then you're going to cut the end of it, you've just compounded the problem. So when I put this on, it's going to go off to that one, okay? Because it's going to swing into position. And depending upon the length of the spout, the clay body, and its own characteristics, the maker, whatever else, other factors that you want to throw in there, those things probably all affect the amount of twist that's going to occur. So I'm going to do this for me, and you're going to go, oh, it needs to be, Scott's going to be heading off to Hillsboro, and it's going to come into line. But it may be slightly different for you. So I'm making this judgment right now. I'm getting an idea about the fit. I'm going to very roughly mark what are we talking about? The amount?
Well, I'm wondering if temperature, higher temperature would create more torque
out, then you lower your firing temperature. You see a little less shifting. And yeah.
I think it would be to say no. So
I
formulated, right?
I shouldn't think it would change it. I think everything should be the same.
You could down into middle.
Well, you're down into that earthenware stuff. No nothing, except it's a problematic thing when it fires one thing. Isn't that true? I'm going to put some holes in. You can have a great discussion about whether it should be one big gigantic gaping hole or whatever. I used to use a drill, and it's always amazing what you learn from sometimes students who said, "Oh, why don't you use a straw?" I like putting an interesting, because the straw's not working this way. I like putting a fairly interesting pattern. Sometimes you sit here and you labor over this part of the process, and you realize that after the spout goes on, nobody's probably ever going to see the intricacy of the pattern that you're putting in there, but you do it anyway. This is a little firm. The straw is not cooperating, so I'm not even getting round holes. So I'm glad that the opening of the teapot is as small as it is. And I really think that the straws that Burgerville has and Starbucks are better than some of the others that are out there.
Are those plugs going inside?
Some are going inside, some are hanging up, which you want to make sure you get them all cleaned up. It's also a good idea sometimes to thin out the clay wall. If you look at it and it looks like for some reason the wall at this point is a little bit thick, you might thin it down by just taking a fettling knife like this one and trimming a little bit of clay away. I don't need to do it here, but if you do that, you reduce the thickness of the bisque, and when you glaze the inside, then it's receiving less glaze and less chance of plugging the holes, which has happened in my career. And it was very distressing because I didn't test the teapot before I put it out. The customer said, "It doesn't pour." And I said, "Well, what do you mean it doesn't pour? It doesn't pour well?" And she goes, "No, it doesn't pour." So I'm scoring this. And for those people who are just here this afternoon, I weren't here this morning, what I'm sticking this in is a slip of clay, but it is actually of such great quality. It's the bottom of my throwing bucket, and I never empty my throwing bucket. So it just sits in there and becomes this stuff. Actually, that might be too extreme. That looks like too extreme, so I'm going to trim that differently. And I talked just a few moments ago about complex parts in terms of stresses. This was thrown out as a cylinder and it's got a twist in it. This is thrown as a cylinder and it's got a twist in it. All of a sudden right here, I have these pieces that are coming together that as they shrink and dry may not be fit together well. And what I'm going to do is I'm going to take a very teeny little piece of clay. Just isn't very much. Roll it out into a little coil. And I'm just going to slide it right down in that corner and work it in with my fingers or a tool. And it helps fit those pieces together. The other thing that I will do is probably helps more than anything else, and I'll be sure and dry this relatively